Hi dear students, with this presentation I would like to discuss about the basic concept of a fuel cell. Fuel cell is similar to our normal battery. You all might have seen the battery. An anode will be there, a cathode is there, as well as an electrolyte also will be there in a particular battery or a cell. So the main difference here also we will have all these things common to the battery. We will have an anode, we will have a cathode as well as an electrolyte separating these two electrodes also will be there. Same as in the case of battery, but only difference is in case of battery, once its charge is lost or whatever is fed inside is a permanent one. Once the chemical reactions are over, we have to either throw it away, otherwise we have to recharge the battery again. But in the case of fuel cell, continuous supply of fuel will be there. uh, Out of that, some chemical reactions are taking place, and continuously we are getting the electricity as the output power. So that is the main difference. A fuel cell is a electrochemical cell. See, it is a electrochemical cell. So some chemical reactions are taking place in order to produce the electricity. So a fuel cell is a electrochemical cell that converts the chemical energy of a fuel. Usually the fuel will be hydrogen and an oxidizing agent. Usually the oxidizing agent used is oxygen into electricity through a pair of redox reactions. So through a pair of redox reactions, we are converting the chemical energy of a fuel into electricity. Of course, in petrol and diesel, we are converting the chemical energy of the fuel into heat energy, but here there is no conversion into heat energy. Instead, we are converting the chemical energy into electricity. That is the main difference. So here also combustion is there, but not the normal combustion. In case of normal combustion, what we are getting is fuel is combined with oxygen to produce heat, but here instead of producing the heat, we are going for some chemical reaction. So as a result of that chemical reaction, we would be able to produce the electricity. Anyway, in the upcoming slides we will discuss it in detailed manner. A fuel cell system has a matching pair of electrodes. So just like in battery, here also we will have a matching pair of electrodes. One is called anode, other one is called the cathode. These are the anode which supplies the electron. So out of this, anode is always supplying the electron, and the cathode which always absorbs the electrons. So these two are separated by a layer, either a solid layer or a liquid layer. That is what is known as electrolyte. Okay, both electrodes must be immersed in and separated by an electrolyte, which may be a liquid or a solid, but which must be either case conduct ion between the electrodes in order to complete the chemistry of the system. So as I have already told, two electrodes will be there. One is anode and the other one is cathode, and these are separated by an electrolyte, which can be either liquid or a solid. But only thing we have to make sure is that in either case it must conduct ion between the electrodes. So ions, whatever ions produced in one electrode, must be passed through the electrolyte to the other electrode. So that we have to make sure, then only the chemical reaction will take place. So in order to complete the chemistry of the system, a fuel such as hydrogen is supplied to the anode. Usually in most of the fuel cell, hydrogen is used as the fuel and it is supplied at the anode. Either hydrogen can be in its pure form or sometimes in its compound form like methane and all we can use. In that case, if it is in a compound form, we have to split it and we have to produce hydrogen to get the or to produce the power. Okay, so that is another concern. See, if hydrogen is being used as the fuel, we have to use it directly. So the production of hydrogen is a complicated process, and also storage of hydrogen in liquid form or gaseous form, whatever it may be, it is also a challenging for the engineers. So that are all the difficulty behind the fuel cells. Okay, so that is the reason why it is not much used in the automobile industries, and otherwise we can have a very good option instead of that conventional petrol diesel fuels. Okay, if enough technology is there to produce that much power, then of course definitely the diesel and petrol are going to be replaced by the fuel cells. So most of the automobiles will be shifting to the electric vehicles side. Okay, so if fuel cell is realized in a with high efficiency, as well as if it can produce much power, then of course it can be used as a it can replace the engine in case of the automobiles. Okay, so a fuel cell such as hydrogen is supplied to the anode. Usually the fuel is supplied to the anode where it is oxidized. So in the anode it will get oxidized, producing hydrogen ions and electrons. So By oxidation, we will be producing hydrogen ions H plus, and of course along with that electrons also will be produced. So an oxidizer such as oxygen is supplied at the cathode. Other side on the cathode we are providing an oxidizer such as oxygen is supplied to the cathode, where the hydrogen ions from the anode absorbs electrons from the latter and react with oxygen to produce water. So whatever ions, hydrogen ions produced in the anode is crossing through the electrolyte to the other side, that is to the uh, cathode side, where we have an oxidizer, that is oxygen. So this hydrogen ion will combine with oxygen on the other side of the electrolyte or at the cathode side to produce to absorb electrons and react with the oxygen to produce the water. So what happens is, see, during the anode side, along with hydrogen ions, electrons are also produced. That electrons is carried through a separate circuit outside, that is used to produce the electricity. With a figure I will explain you in a clear manner. See, here you can see this is the anode side and this one is the cathode side. In between we'll have electrolyte separated, cathode and anode is separated by a layer of electrolyte. It can be either solid form or liquid form, whatever it may be. So from this side we will be supplying the fuel. I have already told mostly hydrogen is used as the fuel, so hydrogen supply will be there in this side. So in anode, due to the redox reaction, the hydrogen is broken down into hydrogen ions plus electron. That chemical reaction is shown here. See, 2H2 is broken down to 4H plus ions. This is hydrogen ions plus 4 electrons, of course. At the anode of an acid electrolyte fuel cell, this is the case of acid electrolyte fuel cell. In the case of acid electrolyte fuel cell, hydrogen gas ionizes, releasing electrons and creating H plus ion. So in the anode, due to that chemical reaction, hydrogen ions are released, hydrogen ions and electrons are released. Okay, so that electrons released will be passing through an external electric circuit which will produce the if we connect it to the load, which will produce the current. Okay, so after it is through that circuit it will reach the electrode, but hydrogen ions produced, it will directly passing through the electrolyte. That's why I have told the electrolyte chosen must be transparent for the hydrogen ions. So hydrogen or whatever fuel we are using, the corresponding ions should be able to pass through this electrolyte. Okay, അങ്ങനെയുള്ള മാത്രമാണ് നമുക്ക് electrolyte ആയിട്ട് യൂസ് ചെയ്യാൻ പറ്റുക. So there is a particular combination. Okay, so hydrogen ions should be transmitted through electrolytes and it will be reaching the other side, that is cathode side. At the cathode side, again recombination of this hydrogen ion electrons along with the oxygen will be there to produce the water. See, O2 plus 4 electrons already produced, which is transmitted through the outer circuit is reaching the cathode. The 4 hydrogen ions which already crossed through the electrolyte is also reaching the anode side. So oxygen is oxidizer or oxygen is supplied at the cathode side through a separate input. See, air is supplied at the cathode side, so air will have always oxygen content, so that oxygen is being utilized for the chemical completion of the chemical reaction. See, this O2 plus 4 electron plus 4 H plus ion will combine to form H2O. So finally the output will be water only. So it is a clean form of energy, we can say. The amount of electric current available to the external circuit depends on the chemical activity and amount of the substances supplied as the fuel. So how much electricity we can produce here is depending on the amount of the substance supplied as the fuel, how much fuel we are supplying here. Okay, so, and as well as it is depending on the chemical reaction also. See, this chemical reaction of converting hydrogen into hydrogen combining with oxygen to produce H2O is a very slow reaction. In some cases, if the reaction is very slow, we have to use the catalyst also. So it is not as simple as we have discussed here. So in reality, it is very difficult to implement all these things and all. So a lot of complications are there. In a sense, we can say in a simple chemical reaction, we can say hydrogen is combining with oxygen to produce electricity as well as H2O. That is the simple chemical reaction we have to explain behind fuel cell. But in actual sense, it is not like that. A lot of difficulties are there. Okay. The current producing process continues for as long as there is a supply of reactant. So as long as we are supplying fuel here as well as the oxidizer here, till the fuel cell will be producing the current. So whenever we want the current, we can supply the fuel as well as the oxidizing agent, then we will get the current as the output. So in the case of battery, we know that once the anode and cathode, power of the anode and cathode is over, or complete chemical reaction has taken place, then only way to throw it away, or we have to otherwise we have to recharge it again. But here, if we want the electricity to produce, only thing we need to provide the fuel as input. So we will get the output as electricity. Okay. Now coming to the chemical reaction, this I have already explained. The anode of the acid electrolyte fuel cell, the hydrogen gas ionizes, releasing the electrons and creating H plus ions or protons. So this is the chemical reaction taking place at the anode side. 2H2 on ionization will give 4H plus 4 electron. That electron will be passing through the external load circuit and it will be reaching the cathode, and hydrogen ions will be directly passing through the electrolyte. This reaction releases energy. At the cathode, oxygen reacts with the electrons taken from the electrode and H plus ions from the electrolyte to form water. So clearly, for both these reactions to proceed continuously, electrons produced at the anode must pass through the electrical circuit to the cathode. Also, H plus ion must pass through the electrolyte. An acid is a fluid with free H plus ions and so serves this purpose very well. Usually, the electrolyte will be acid. The reason will be it is free. Acid is a fluid with free H plus ion, so it will readily it will allow H plus ion to readily pass through it. So that's why most of the cases electrolyte used is a acid. Okay, and so serve this purpose very well. Certain polymers can also be made to contain mobile H plus ion instead of acid liquid. Sometimes solid polymers are also used as electrolyte that also will transmit the H plus ion readily. Okay, now based on the which of the electrolyte used and the types of the fuels used in fuel cell, the fuel cells are mainly classified into these categories. First one is solid oxide fuel cell, SOFC in short. Here in solid oxide fuel cell, everything is having the same structure like this. See, one anode will be there, one cathode will be there, separated by electrolyte, that's all. And to pass the electron, we will have an external circuit where we will get the current, and through the electron, ions will be passing. Okay, so coming to the solid oxide fuel cell, electrolyte used is solid ceramic such as stabilized zirconium oxide. A precious metal catalyst is not necessary. Here there is no need of metal catalyst is required. Can run on hydrocarbon fuel such as methane. See, usually in SOFC fuel cells, instead of direct hydrogen, methane is used as the fuel. Of course, it has to be decomposed into hydrogen, then only we can produce the hydrogen ion. Okay, operates at very high temperature around 800 degrees Celsius, 1000 degrees. This is the only one operating at a very high temperature. Best run continuously due to the high operating temperature, popular in stationary power generation. Coming to the next one, proton exchange membrane fuel cell, simply PEM fuel cell, we'll call it as PEM fuel cell. Here electrolyte is water based acid polymer membrane, that is the electrolyte used, also called polymer electrolyte membrane fuel cells. That's why it is also known as polymer electrolyte membrane fuel cells. Use platinum based catalyst on both electrodes. See, here there is no catalyst is required in case of SOFC, but here usually to speed up the chemical reaction, platinum based catalysts are used in both the electrodes. Generally, hydrogen is used as the fuel and operate at relatively low temperature below 100 degrees Celsius. High temperature variants use mineral acid based electrolyte and can operate up to 200 degrees Celsius. Electrical output can be varied, ideal for vehicles. These are all the PEMFC, okay, proton exchange membrane fuel cells. Now coming to the next classification, that is alkaline fuel cells, AFC simply it is known as. Electrolyte is alkaline solution such as potassium hydroxide in water, that is the electrolyte used. Commonly used nickel catalyst, here also catalyst is required, and the commonly used catalyst is nickel catalyst, generally fueled with pure hydrogen and oxygen as they are very sensitive to poisoning. Okay, pure hydrogen and oxygen is generally pure hydrogen is used as the fuel, and pure oxygen is used as the oxidizing agent. Okay. Typical operating temperature is 70 degrees Celsius, can offer high electrical efficiencies, tend to have relatively large footprints used on NASA shuttles throughout the space program. Okay, that's all about alkaline fuel cells. Now next one is direct methanol fuel cells. Electrolyte used is polymer membrane like PEMFC. Here also we have used PEMFC, also we have used polymer membrane as the electrolyte. Similarly, in direct methanol fuel cell also we will be using polymer membrane as the electrolyte. See, as the name indicates, direct methanol. So methanol will be used as the fuel, I think. Use platinum ruthenium catalyst on the anode and platinum catalyst on the cathode side. See, both in anode side as well as cathode side we require the catalyst, and platinum or ruthenium is used in the anode side as the catalyst, and platinum is used as the catalyst in the cathode side. This catalyst can draw hydrogen atom from liquid methanol, which is used as fuel instead of hydrogen, giving the cell its name. Okay. See, why we are using catalyst in this case is this catalyst can draw hydrogen atom from the liquid methanol. See, we are using methanol as the fuel here, so from that we have to extract out the hydrogen. So that is being done by the this catalyst. Okay, so catalyst will absorb that hydrogen from the methanol, and of course it is ionized by the chemical reaction, which is used as a fuel instead of hydrogen, giving the cell its name. That's why its name is direct methanol. Operating range of 60 to 130 degrees Celsius. DMFC are convenient for portable power application with output generally less than 250 watt. Okay, that's all about DMFC. Now coming to the next one, PAFC, for phosphoric acid fuel cell. Electrolyte used is liquid phosphoric acid in bonded silicon carbide matrix. Use a finely dispersed platinum catalyst on the carbon, quite resistant to poisoning by carbon monoxide. Operate around 180 degrees Celsius. Electrical efficiency is relatively low, but overall efficiency can be about 80% if the heat is used. Used in stationary power generators, 100 kilowatt for high power application. We are going for this one, phosphoric acid fuel cell, but it is commonly used for stationary power generators only. Electrolyte used is phosphoric acid in bonded silicon carbide matrix. Okay, so see, all these fuel cells are basically different from others based on its which electrolyte is being used, and as well as the which fuel is being used. Mostly the fuel used will have some hydrogen content in most of the cases, and of course oxidizing agent, or the cathode side we will be supplying oxygen as the fuel. Okay, so the lower figure shows this one. This table shows the comparison between all these types, or we can say in a nutshell what are the mobile ions. We will have an idea. See, in case of alkaline fuel cell, OH negative, OH minus is the mobile ion, and proton PMFC we have H plus. See, direct methanol H plus. Phosphoric acid fuel cell also H plus. See, most of the cases H hydrogen ion is the mobile ion which will cross through the electrolyte. In rare cases only other ions are being used. In alkaline fuel cell, OH minus is the mobile ion, and in case of molten carbonate, that we have not discussed here. In solid oxide, O2 negative, O2 minus is the mobile ion. Okay, so here we have the operating temperature ranges also, and applications are also given here. You can go through it as the application, since your syllabus is dealing with the basic working of fuel cell and how the classifications as well as applications are also there. So the applications as far as university exam point of view, you can have it from here. Okay, so that's all about fuel cell. Thank you.